Welcome. This is Mathisi, Greek word for learning. It focuses on providing insights on different concepts of mathematics, and this channel would release math lectures on a regular basis to provide introductory knowledge to pre-college mathematics. This is math. Alright, so in the third lecture we are going to talk about factors, and within that we are going to talk about firstly prime factors. So prime factors are can be simply said that they are the multiplication of them leads to a number, can lead to any number. So every number can be written as the multiplication of its prime factors with their specific powers. For example, 2 is equals to 2 into 1, 8 can be written as 2 to the power 3 into 1, 250 can be written as 5 raised to the power 3 into 2. So now let's talk about how to count how many factors of a number exist. So for example, 2 can be written as 2 into 1. It means that there are only 2 factors of 2. Now consider 12. So there are 6 factors, 1, 2, 4, 3, 6 and 12. So in order to count them, we need a formula or something so that we can just put the numbers in there and find out the solution. So the formula is, if n, a number, can be written as p1 to the power k multiplied by p2 up to the power k times pn up to the power kn, where p1, p2 up to pn are prime factors of n. Then the number of factors of n is equal to k1 plus 1 into k2 plus 1 up to kn plus 1. So let's see the proof. So as we discussed about prime factors earlier, 12 can be written as 2 raised to the power 2 multiplied by 3. So let's make columns and rows of this, a table of it. 12, the number of factors of 12. So here goes to the power 0, to the power 1, to the power 2, and on the right side there are 3 raised to the power 0 and 3 itself. So every number which is a power of 2 can be multiplied to a different prime number, or like suppose 3 in this case. It can be multiplied by 3 raised to the power 0 or 3 raised to the power 1 and can give 2 different numbers. So we are going to use some PNC here. So we are going to take one number from the left hand side and one number from the right hand side, which means that one number from either one of it, to the power 0, to the power 1 or 2 raised to the power 2. So it is 3c1, and from 3 raised to the power 0 and 3 raised to the power 1 we are going to take just one number which can be taken through 2c1 number of ways. So the number of factors can be written as 6. The number of factors of 12 can be written as 3 multiplied by 2 equals to 6. Alright, so another example, 144, which is square of 12, can be written as 2 raised to the power 4 multiplied by 3 raised to the power 2. So in the same way it can be written in a tabular form, where the left hand side, the left column denotes every power of 2 and the right hand side denotes every power of 3 it contains. Alright, so every power of 2 can be combined with another power of 3 to give a factor. So because there are 5 powers of 2 from 0 to 4, we'll take just one of them, which is 5c1, and from the 3's column we are going to take just one number in 3c1 number of ways. So the number of factors of 144 are 15. And now let's talk about the even factors. How many even factors does a number have? We are going to count that. So let's take an example, 144. Suppose. So in even factors mean it is a multiple of 2. So we are except for 2 raised to the power 0, we are going to take every power of 2 from 1, 2, 3 and 4. Alright, so we are simply just cancelling out the 2 raised to the power 0. So now we have only 4 rows in the first column and 3 rows in the second column, which are 3 raised to the power 0, 3 raised to the power 1 and 3 raised to the power 2. So again we are going to use some permutation and combinations which would lead to the number of factors equals to 4c1 multiplied by 3c1, which is 12. So there are 12 even factors of 144, and the number of odd factors are simply 15 minus 12, which is 3. Or we can do a simple multiplication again, where we are not going to take any power of 2 except 2 raised to the power 0. So now on the left column there is just one term, and on the right column there are 3 terms. So the number of odd factors would be 1 multiplied by 3 equals to 3. Alright, so in this way we can find the number of factors of any number, so to say. And in the next lecture we are going to see some more combinations of factors, and we'll try to find out remainders when a number is divided by another number using the theorems we learned in the last lecture, and this counting the number of factors method. Alright, thank you.